Hey, welcome to Unit 5, Section 6. It's the holiday times, and we're learning about kites and trapezoids. And to celebrate the holidays, we're going to show a couple of movie clips from our favorite holiday movies. So I bet you've seen some of these. Here's the first one coming up right here, one of my favorites.
Catherine, this turkey tastes half as good as it looks. I think we're all in for a very big treat.
Save the neck for me, Clark.
Okay, Eddie.
That's National Lampoon's Christmas Vacation, one of my favorites there. First thing we're going to talk about are kites. And a kite is quadrilateral with two pair of consecutive sides congruent. In other words, it's like a parallelogram, but they put the pieces that are the congruent next to each other. Like here and here. These are the congruent pieces here, and congruent pieces on these sides. Okay? The opposite sides are not congruent. So here's what the theorem is. If a quadrilateral is a kite, then its diagonals are perpendicular. So that's one thing we know about kites. Look, if we draw the diagonals, then they're perpendicular from each other. And one of the things that you're going to be asked to do is find the measure of angles. They might give you this angle here is 42 degrees. They want you to find this angle up here. So let's talk a little bit about what happens when you actually draw these diagonals. What you get, if you look at the triangle on the right there, let's erase what we have. If you look at this triangle, look at ACB, this triangle up here. Okay, already because it's a kite and this side is congruent to, we have AB congruent to AD, and then BC is congruent to CD, we get two sets of triangles here. They're going to be congruent if we do the reflexive property by side, side, side. And because they're congruent, we can say a couple things. Their corresponding parts are congruent. So what does that mean? If this angle in here is 10, then this angle down here is 10. Okay, what about this angle here? Well, this corresponds with this angle here. So angle BAC corresponds with DAC. And so if, I don't know, BAC is 42, then maybe DAC is also 42. Notice that this angle down here is not necessarily the same as this one. Okay, they have nothing to do with each other. Okay, so once you find out one of these angles, because the diagonals are perpendicular, you can find out the other angle because they all have to add up to 180. All right, so if all three of these add up to 180, you already have 90 and 10, that's 100, so this one must be 80. All right, how about on this side? We have this side is going to be 90 because it's perpendicular. So if this side is 42, then they all have to add up to 180, so 42 plus 90 is 132. And then plus x, so we can write a little equation there to solve that. Let's actually look at a real problem right here with real numbers in it that I've given you. That you have to find all of the unknown angles. All right, so I'm going to start with 1 because 1's the easiest. This is a kite, and we know that because the consecutive sides here are congruent. Same thing on this side. All right, you can kind of see how it looks like a kite. Angle 1, that's where the diagonals are perpendicular and they intersect there, so that's going to be 90 degrees because we know they're perpendicular. All right, now what? Well, if what do we got? I can figure out this. This is 38 degrees. Okay, remember the picture before how we did two triangles? All right, so side, 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 congruent to side, side, side. If this angle here is 38 degrees, and then the angle down here, number 3 is also 38 degrees, so we can fill that in. Okay, so the question is, can we just say that the diagonals bisect the angles? Yes and no. This diagonal here that cuts between the two pair of consecutive sides, that angle does bisect. All right, this is also 53 because they're corresponding. But this angle running vertically here, that does not bisect. You can kind of tell that 2 is a little bit larger than 4. Okay, so you have to be careful in the way that you're looking at the diagonals. What did we just figure out? That 5 equals 53. All right, and again, that's because we have triangles congruent and we have side, 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 so the corresponding parts are congruent. All right, so now what can we figure out? Angle 2, well, if this, what do we have here? We have 90, so 90 plus 38 plus angle 2, that should all equal, let me put my angle sign in there, angle 2 plus 38 plus 90, that should all equal 180 because you get a little triangle right there. All right, so we get 128 plus the measure of angle 2 is going to equal 180. What do we do? Subtract now. 128. Subtract 128. Draw a line. The measure of angle 2 equals, what do we get here? Maybe a 52. Alright, so the measure of angle 2 equals 52 degrees. Okay, how about the measure of angle 4? If this is 90 and this is 53, I'm going to be honest. The way I normally do this, I say this is 90. You know they all equal 180. So if this is 90, these other two have to equal 90. So what number plus 53 is 90? That's how I do that one in my head. I get 37. I can figure that out. That's angle 4. Notice how they're different. They're not all the same as each other. All right, so that's how kite angles work with the perpendicular diagonals there. Here you have a kite with just that one diagonal down the middle that splits it into two congruent triangles. And so in this question you're asked to solve for x and y. So I'm going to look first at the top angle and the bottom. Those correspond in our two triangles. Remember, side, side, side. So I can actually set them equal to each other. And that's good because we have x's and x's. So 4x minus 30 has to equal 3x plus 5. So if I subtract 3x from each side, when we get 1x minus 30 equals 5, add 30 to both sides, x is going to equal 35. That's good enough. Let's try the y now. Okay, now solving for y, what are we going to do here? Well, let's first, I'm going to look at the triangle on the top, or you can look at the triangle on the bottom, but I'm going to look at the triangle on the top. And we have y here. I don't know what that is. How much is this angle over here on the right? It's the same as this angle here. Remember that if it goes down the middle, it's going to bisect these two. But not this one. All right, so we get 2y minus 20. That's this angle here. All right, now what about the top? 3x plus 5. Well, we just know that x equals 35. So if we plug that into 3x plus 5, 3x plus 5, what do you get? 3 times 35, 105 plus 5 equals 110. All right, so this angle up here is 110 degrees. So what do we have now? A nice little equation because we have a triangle at the top, triangle sum formula. So we get y plus 2y minus 20 plus 110. That should all equal what? How many degrees are in a triangle? 180. All right, let's do some simplifying. Combine some like terms. We get 3y plus 90 equals 180. I think when you solve it, when you subtract 90 from each side, can we do this in our head? I think so. Y equals 30. All right, done with that one. We got x and we got y. I'm going to box our answers there so Mr. Breast doesn't throw a fit. Next question. Okay, find the measure of angle 1 and the measure of angle 2. Try this one all by yourself. Pause the video. Go! Pause the video. Okay, so let me show you how I would do this one. Maybe you did it a different way, but I would use the fact that this is a quadrilateral. It's got 4 different sides, so it's n minus 2 times 180. That's the formula for the total sum of the interior angles. So 4 minus 2 times 180, that'll give you 360 degrees. And so now I can write a formula, 90 plus, well, let's see, angle 1, which we don't know, so I'm going to call that x. Here we go, that's x. Angle 2 is also x because they're congruent. All right, so 90 plus x plus 48 plus x, all that should equal 360. La, 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 la. You solve it, you get x equals 111. So that's the measure of angle 1 and the measure of angle 2. I'm going to show you a different way to do it now, and maybe this is the way that you did it. All right, so we're going to draw a diagonal through these two angles here. And if you notice the top of this, like the ice cream part of the ice cream cone, that's an isosceles triangle. So we have 90 degrees here. 90 plus x has to equal 180. Each of these will equal 45. All right, so that's 45. This is also 45. You can play the same game down here. You have two different angles. All right, I'm going to call them y just so we don't mess up our x's. All right, so y and y. So 2y plus 48 has to equal 180. All right, what's that going to give us? 2y equals, what do we get there? 132 when we subtract. And you get, what do we get? Divide by 2, so you're going to get 66. So y equals 66, and that's this half of it here. So now we must do the 66 plus the 45. You get 1 plus another 1, 111. That is a different way to do it. What is a third final way to do this? Kelly, you're killing us with all these different ways to do it. You're going to, so student, I'm so confused. I'm confused. All right, so if you draw a line down the middle here, these angles are bisected here and here. All right, so this one is 45. This one would then be 24. This one, they all have to add up to a right angle. So what do we get here? So let's see, 45 and 24, that's 69. 180 minus 69, let's try it. 180 minus 69. What do we get there? 7, 1, 1, 1. Oh, 111. Booyah! That's the different ways you can do that kite problem. There's 3 different ways to do it. Let's talk about trapezoids now. Nah, let's first watch another movie clip.
I don't think so.
Doubt? Another unmistakable sign of the heebie-jeebies. No, you're doomed. Run for your life before I kill again! I'm a psycho. Danger! Danger!
Is it just me, or does that guy remind you of Brust? Anyways, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Let me show you in each one of these trapezoids where that parallel side, or where those parallel sides are. Okay, the first one's called a scalene trapezoid. All the sides are a different length. All right, a right trapezoid. Okay, a right trapezoid has a right angle. Okay, in this case, it's down here in the bottom left. Here are the parallel sides. And an isosceles trapezoid, just like an isosceles triangle, but it has one pair of parallel sides, and then the other 2 sides are called legs. And an isosceles trapezoid has 2 congruent legs. All right. So the non-parallel sides of the trapezoid are called legs. Just said that. It's a right trapezoid. If the legs are congruent, the figure is called isosceles. Hey, I just talked about all that stuff. We have a couple theorems. The base angles of an isosceles trapezoid are congruent. Okay, so the bases are the parallel sides, and then the angles that come off the parallel sides, those are called base angles. So you can tell here they're both obtuse. They're congruent to each other. Down here, they're also base angles. You can see that it's labeled. Those are congruent to each other. The legs are also congruent to each other. Okay, so these are things that are true about an isosceles triangle. The last part deals with the diagonals, the second theorem there. If we draw the diagonals in, all right, so from here to here, and from here to here, they are also congruent for an isosceles trapezoid. So let's do some problems now, some examples using our new theorems. Okay, the first one, if you look, it's an isosceles trapezoid. I can tell because it has it marked right here. Same's true for the second problem. I can just zoom in there. But it's an isosceles trapezoid, so I know the base angles are congruent. So 60 and 5x, those are the same. S is congruent to R. So we can write a little equation, 60 equals 5x, and when you solve it, you get 12 equals x. Make sure, it says solve for x up here, so we're all done, but make sure it doesn't ask you to say, okay, so then find angle T. And we'll show you how to do that when we get to this one here. Okay, so the second example, what do we have? SU, that's this diagonal right here, and R, what do we have? TR. Okay, so they're giving you different lengths. So SU is x plus 1, and TR is 2x minus 3. These are diagonals. It's isosceles again, so that means the diagonals are congruent. So we can write an equation, 2x minus 3 equals x plus 1. And then we can solve it, minus x, draw a line, x minus 3 equals 1. Add 3 to both sides, we get x equals 4. And again, they're asking us to solve for x, so we're done there. All right, how about, let's get out the highlighter. Let's look at the third example. Here are the parallel sides on the top and the bottom. And look, we have here a transversal. Sully taught this. What type of angles are these? These are called same side interior. What do we know about those? They are supplementary. So that means that 60 plus 32x minus 8 should all equal 180 because they're supplementary, same side interior. Now we can solve this equation, 32x. What do we get? Plus 52 equals 180. All right, 180 minus 50. We're going to have to subtract 52 here. 52 from each side. If you subtract 50, you get 130. Subtract 2 more, you get 128. So 128 equals 32x. And I'm guessing that x equals 4 for that one. Hey, look at that. 2 4s in a row. Let's find another clip. Let's watch another clip. Christmas
okay,
movie.
people, tomorrow morning, 10 a.m., Santa's coming to town.
Oh my God! Santa here? I know him. I know him.
He'll be here to take pictures with all the children.
Yeah.
Just keep your receipts. 10 a.m. tomorrow.
10 a.m. tomorrow.
Santa's coming to town.
Yes. Sign this for me.
Maybe it's just me, but a lot of these characters remind me of Brust. All right, let's talk about what a mid-segment is. The mid-segment of a trapezoid. Ooh, mid-segment. That's a new word for us. Ta-da! Mid-segment is the line that connects the midpoints of the two legs. All right, so here's a random trapezoid. Find the midpoint of the legs. Remember, the legs are the sides that are not parallel. So here's the midpoint here. Ooh, let's use a different color. Let's actually use color on this. Color! Come on. Midpoint here, midpoint here. If you connect the two midpoints, that's called the mid-segment. Sometimes they call it the median, but we're going to call it the mid-segment. Well, here's what we know about the mid-segment. Let's look at it first and see if we can figure it out. This mid-segment is a little bit longer than the small base and a little bit shorter than the longer base. It's right in the middle. In fact, it is the average size of these two bases. If you find the average of the bases, that'll tell you the length of the mid-segment. So here's what the theorem is. The segment, parallel, we didn't talk about that yet, but it's also parallel to the bases, and it measures, the important part is it measures half the sum of the bases. So if I add the two bases and divide by 2, I get the mid-segment. So what does that look like with numbers? Add the two bases. Let me put an x on here. X. All right, so what does x equal? X equals the average of the two bases. The average is 24 plus 30, and you divide that whole thing by 2. So that's going to equal 54 divided by 2, which is 27. So if I throw x equals 27 here, all right, so 24 to 27 is 3, and from 27 to 30 is 3. It's the same distance. This is in the exact middle of 24 and 30. All right, let's try number B, letter B, letter B. All right, so the mid-segment is the average of the two bases. So I'm going to find the average of the two bases. So here's how I would write that. It's 4x minus 10 plus 8 divided by 2. That is the average of the two bases. That should equal the mid-segment. All right, so now it's just a little simple combine like terms. 4x minus 2 all over 2 equals x plus 2. And how can I solve this equation? Do you remember going back to algebra? Do I need to do those like that harp noise where we go back in time? Cross multiply. Let's throw that over 1. We'll cross multiply. We get 2 times. Don't forget your parentheses. X plus 2. That should equal 1 times, I don't need to write that, 4x minus 2. This is a very simple equation. We can do a little distribution here. 2x plus 4 equals 4x minus 2. What if I subtract 2x from both sides? Here's the line down the middle. Remember this? Cancel. 4 equals 2x minus 2. All right, then what do we got? Add 2 to both sides. Add 2. Mr. Kelly's showing all the steps. Okay, except that last one, x equals 3. Let's go back up and see if x equals 3 makes sense. That's what we got. X equals 3. Okay, so we draw it there. If x equals 3, then 3 plus 2, this mid-segment is going to be 5. If x equals 3, then 4 times 3 is 12, minus 10 is 2. Is 5 directly in the middle of 2 and 8? Yes, it is. That's what the mid-segment is. Easy enough. Let's have you try one. Pause the video and try this one all by yourself. All right, so here is my equation that I start up with. Let's see if we can figure out how Mr. Kelly got this. So 16x minus 24, that's what I have right here, plus 20, that's what I have right here. If you add them up and you divide by 2, it should equal the mid-segment, 4x plus 22. Now I'm going to combine like terms. Right up here I can combine like terms. So 16x, what do you get? Minus 4 all over 2 equals 4x plus 22. Now we can cross multiply. I'm going to put that over 1. Cross multiply here. Don't forget your parentheses. 2 times 4x plus 22 equals, and when you cross multiply here, you get 16x minus 4 times 1. So I don't need to put that. All right, now what are we going to do? Let's give me some more room. Distribute. Everybody loves to distribute. 8x plus 44 equals 16x minus 4. If I subtract 8x from each side, I'm going to get this equation here. If I add 4 to each side, I get this equation. And if I divide by 8, I get x equals 6. Oh my goodness. Should we plug it in? Yeah, let's plug it in. So plug a 6 in. 24 and 22 is 46. Ta-da! Plug a 6 in. 16 times 6 is 96. Minus 24, that's 72. That's this. Now look, from 20 to 46, that's plus 26. You add another 26, you get 72. So 46 could be a reasonable mid-segment, which means that x equals 6 could be reasonable. Man. So that is everything you need to know about trapezoids and kites. We're all done. That's Unit 5, Section 6, the very last section. Go do the homework, practice it, do it all. You know how to do it. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. Here's one last scene of Ralphie, who reminds me a lot of Mr. Sullivan, by the way.
Triple dog dare.
I triple dog dare you!
Schwartz created a slight breach of etiquette by skipping the triple dare and going right for the throat.
All right. Come on, Karen. Well, go on, do it. I'm going.
Flick's spine stiffened, his lips curled in a defiant sneer. There was no going back now.
This is next.